The last set of problems here are concerning differentiation rules. So we do need to have these rules available to us as we work with more advanced integration techniques. Problem 5 asks for what is the derivative of the cosine of 2x. So this is a chain rule problem. Since inside I've got 2 times x, I will say that the derivative of the cosine function is minus the sine. I keep the 2x inside, and I need to multiply by that derivative, which is 2. The problem after this, problem number 6, asks us for the derivative of 1 divided by the square root of x. I'm choosing to make this easier on myself by saying that first off, the square root function is really x to the power 1/2, and that dividing by a power of x is the same thing as having that same power of x, but the exponent is going to be the opposite sign. This lets me set up the problem as a power rule derivative. So I bring down the old power as a coefficient. I multiply by x, and my new power is 1 less than what we started with. So minus 1/2 minus 1 is going to be minus 3/2. There it is. Problem 7 is another chain rule problem. E to the power t squared. So my f of x is e to the, oh, excuse me. This is written in terms of the variable t. How about that? My outside function is going to be e to the power t. My inside function of t is going to be t squared. Now, the exponential function is its own derivative, so there's my f prime. The derivative of t squared is 2 times t. So once again, I just put my pieces together. The solution is going to be e to the power t squared times 2t. Problem after this, another problem with the variable t. We have the cosine of 5 times t times e to the power 5 times t. This is a product rule problem. So first I say, take my original function, multiply by a derivative of e to the 5t. And I know that that derivative must be e to the power 5t times 5. There's sort of a hidden chain rule in this problem. And I need to add to this the derivatives going the other way. Keep the e to the 5t the same, take the derivative of the cosine. E to the power 5t is going to stay the same. The derivative of the cosine is minus the sine of 5t times 5. So there is this derivative. Starting at problem 9, I'm using the letter g for my function instead of the letter f. We can call our functions whatever we like. This function is square root of 1 plus t squared. And again, I am going to rewrite this as a power rule. This is another chain derivative problem. So if I'm just taking the derivative of x to the power 1/2, I have x to the 1/2 on the new outside as a coefficient, and minus 1/2 is my new exponent. On the inside, I keep the function 1 plus t squared just as it was. I need to multiply by the derivative of the stuff inside the parentheses. Derivative of 1 is 0. This is just a constant. And the derivative of t squared is 2 times t. The very last of these problems is the hardest one from this assignment. I want us to calculate the derivative of this function. G of t is the tangent of t times t squared. And then we are going to add on tangent of the square root of t. I would recommend that we break this function into two pieces. One of them will be tangent of t times t squared. The other of them will be tangent of the square root of t. Doing them separately lets me focus on getting all the details right. At the very end, I can add those back together. So, first, I'm going to calculate the derivative of this function. This is just the product rule. So I'll say I've got tangent of t times the derivative of t squared. I know that's 2t. And I need to add to that the derivatives going the other way. Keep the t squared the same, and I know that the derivative of the tangent function is secant squared of t. That's all I need there. Next, I'm going to take the derivative of the other part of my original function, the tangent of the square root of t. This is a chain rule. My outside function is the tangent. My inside function is the square root. I know that my derivative of the tangent function is secant squared. So this will be secant squared with the square root of t inside of it. And I then need to multiply by the derivative of the square root, which is 1/2. And I'm going to choose to write this as 1 divided by the square root of t. You could also write 1/2 times t to the minus 1/2 power. It means exactly the same thing. So now this derivative and this derivative, these are the ingredients for the actual answer to my problem. I can report that g prime of t is the sum of these two formulas. So I get tangent of t times 2t plus secant squared of t times t squared plus secant squared of the square root of t times 1/2 1 on root t. There's a little bit we could do to clean up this formula, but in terms of exercising our derivative muscles, that's all I'm looking for today.